In Lesson 3-2, we will be discussing logarithmic functions. In Video 3.2.5, our learning target is to sketch and analyze graphs of logarithmic functions. In Example 5, we will be discussing the graphs of logarithmic functions. We are going to sketch and analyze the graph of f of x equals log base 2 of x and describe its domain, range, intercepts, asymptotes, end behavior, and where the function is increasing or decreasing. So the function f of x equals log base 2 of x was given to us, and we can rewrite that as y equals log base 2 of x. That is the logarithmic form of that function. Now what I can do is every log form can also be, or every log function can be rewritten exponentially, which could be 2 to the y equals x, right? 2 to the y equals x. Now, what I want to do is I want to graph this function, 2 to the y equals x, which is the exact same thing as saying y equals log base 2 of x. Now, in order to graph this function, this time y is my independent variable, and x is my dependent variable because x is by itself. And I'm going to go ahead and choose values of x, for y this time. -3, -2, -1, 0, 1, and 2 are the choices I've made for y. And then I'm going to go ahead and find x. So if I substitute -3 for y, that's 2 raised to the -3, right? 2 to the -3 is equal to 1 over 2 cubed, which is 1/8. 2 raised to the -2 is 1 over 2 quantity squared, or 2 squared, and I get 1/4. And 2 to the -1 is equal to 1 over 2 to the first, which is 1/2. 2 to the 0 is equal to 1, 2 to the first is equal to 2, 2 squared is equal to 4. Now, what we're going to do is we're going to go ahead and graph this function on the next slide and then analyze its domain, range, intercepts, asymptotes, end behavior, and where the function is increasing and decreasing. Plotting the points that we created in the table on the last slide, we get a graph that looks like this. Okay, logarithmic functions generally are, unless they're translated or transformed in some way, are going to be graphed in quadrants 1 and 2. No, sorry, rather 1 and 4, so that your x values are always positive. Now, a logarithmic function can never be evaluated for a negative number. Therefore, our graph is always going to be in quadrants 1 and 2. Sorry, 1 and 4. And exponential functions are always in quadrants 1 and 2. Now, looking at this function, we need to determine the domain. Since our graph is only in quadrants 1 and 4, we would say our domain is going to be from 0 to infinity, not including 0 because this graph is never going to touch the y-axis where x equals 0. Your range is going to be from -infinity to infinity. Your x-intercept is at 1. You do not have a y-intercept. This time your asymptote is not horizontal, it's vertical instead. So we're going to say x equals 0. Right? X equals 0 is the y-axis, and our graph is going to approach the y-axis but never intersect it. And we want to know whether the function's increasing or decreasing. As I move from left to right, right here you can see that our y values are increasing. So we'll say that our function is increasing from, this should be a C, increasing from -infinity infinity to infinity. Our end behavior here is as x approaches, the limit as x approaches infinity for the function is going to be infinity. Our other end behavior is the limit as x approaches 0 from the right side, because you can't approach 0 from the left side of the axes because there is no part of the graph in quadrants 2 and 3. So as we move from right to left, so basically as we move in this direction along the graph, as we're approaching x from the positive side of things, we are going to look at our limit being negative infinity. Right? Because our end behavior right here, our arrow's pointed down, so our y-coordinate is approaching negative infinity. In example 5, part B, we're asked to sketch and analyze the graph of g of x equals log base 1/3 of x. We're going to describe its domain, range, intercepts, asymptotes, end behavior, and where the function is increasing or decreasing. Now realize the function g of x equals log base 1/3 of x can be rewritten as y equals log of 1/3 of x. Log base 1/3 of x. Now, every logarithmic equation can be rewritten exponentially. This log function can be rewritten as 1/3, base of 1/3, to the power of y equals x. That's log form. This would be exponential form. Now, what you need to do here is go ahead and graph 1/3 to the y power equals x, and we'll do that by selecting values of y and then finding x. 1/3 to the y equals x was our function, and I'm going to go ahead and create a table. And like I said in the last slide, I'm going to select values of y. Y is my independent variable. X is dependent because it's by itself. So therefore, 1/3 raised to the y, I'm going to pick, let's see, -3, -2, -1, 0, 1, and 2. And let's go ahead and pick 3 as well. If I input -3 for y, I get 1/3 raised to the -3 power, which is the same. Anytime we have a negative exponent, we take the reciprocal of the number we'll just say we'll take the reciprocal of our base, so 3 over 1, and then we raise that number to the positive exponent, so the negative takes the reciprocal of our base, and then we raise that to the positive exponent of 3, so we get 27. And if I take 1/3 to the -2, it's equal to 3 over 1 squared, which is 9. 1/3 to the -1 is just going to be 3. 1/3 to the 0 power is 1. 1/3 to the first is 1/3. 1/3 squared is 1/9. 1/3 cubed is 1/27. So now what we need to do is we need to go ahead and graph these points to see what our function looks like. So all the way out at 27, 3, 6, 9, 15, 12, 15, 18, 21, 24, 27. Okay, at 27 we would be at -3. And at 9 we'd be at -2. Since I counted by 3's here, 3, 6, 9, I'd be down here at -2. At 3 I'd be at -1. At 1 I'm at 0. 1/3 I'm at 1. My function looks something like this. Okay, again, we're in quadrants 1 and quadrants 4. And what I want to do here is analyze this function. So first of all, what is our domain? Well, since we're in quadrants 1 and 4, our domain is going to be not negative, 0 to infinity, right? In quadrants 1 and 4, we have this asymptote here, this vertical asymptote, and our graph is going to approach that axis but not touch it. Our range here is going to be from negative infinity to infinity. Our intercepts, we have an x-intercept at 1, but no y-intercept. Looking at our end behavior would be as the limit approaches infinity, our y value would be approaching negative infinity. So the limit as x approaches infinity of the function, y is approaching negative infinity because this arrow is pointed downward and to the right. And the limit as x approaches 0 from the right side or from the positive side, our end behavior would be infinity because this end right here, as x gets closer to 0 from the right side of the graph, because we can't approach 0 from the left side of the graph because the function is not defined in these quadrants 2 and 3, you would say your limit then is infinity. And again, the reason why our limit is infinity is because our end behavior is pointed up. In example 5 guided practice, I would like you to go ahead and describe the end behavior of the function f of x equals log base 4 of x. You have 4 choices, A, B, C, and D. So what you should do is graph the function f of x equals log base 4 of x and then determine the end behavior. Once you have selected your answer, press submit and you're finished.